Hi, everyone. Welcome to the November community call for Pyroscope. If you haven't been here before and you are wanting to try commenting and it doesn't let you for some reason, if you click on the top right corner with your image, you can go and create a channel. We would love if you could ask questions throughout. If there's anything you have that you want to know or any comments you want to make, that would be super awesome. So yeah, basically, we have a few things that we're going to be covering today. So we are continuing on the series that we were doing for intro to profiling for folks to just kind of like if you're maybe newer to it or if you're just trying to get more familiar. So we're going to be doing that about labels and the diff view that we have. So Alex is going to be talking about that, and then we're going to be having Alberto talking about metrics from profiles. And then lastly, we are going to talk about the 116 release that came out yesterday and just kind of telling you a little bit about what's happening there. So yeah, again, if you have questions, comments, etc., please do in the chat. I will be asking these lovely folks whenever you have questions and also things that I might have as well. And so I will kick it off to you, Alex.
All right. Hey, everyone. I'm Alex, and I'm an engineer on the Pyroscope team. So today I will talk about the intro to profiling. As we said, this is a continuation of a previous call where we talked about flame graphs in general and profiling. Today we're going to talk about labels in the Diff view. So this is the brief agenda. So for labels, we're going to talk about what are labels, why do we need labels, a bit about the different kinds of labels that we have in profiling, and then I'll do a short demo using Grafana profiles drill down. And then we're going to do the same for the diff view. Again, we're talking about what is the diff view, why do we need it, how does it work, and then a short demo. So let's start with labels first. So labels are common to all observability signals, like we have labels or tags in metrics and logs and traces. They're key value pairs, and they provide some metadata about the signal. Also provide like a second dimension to the data on top of the time dimension that we have in continuous profiling. Here are some example labels that you might have seen across the different signals and also in profiling. Why do we need labels? Well, typically we profile a lot of applications, and even the same application will be deployed in different regions and different environments, and we'll have different replicas, and they will run on different machine types. So we use labels to narrow down the analysis of the profiling data to a subset of the applications that we profiled. But also labels enable other features, such as the diff view that we're going to talk about later, but also traces to profiles and others. So we'll briefly talk about the different types of labels. And again, this is not specific to profiling. This is common to the other signals, but we still want to clear this up because it's important, and the different kinds provide different flexibilities. So have external labels, which we also call static labels because they don't change for the life cycle of the application. They're not part of the profiles that are being collected, but they're uploaded together with the profiles to Pyroscope, typically with the Grafana alloy components. Like in Kubernetes, we have the discovery components that can collect Kubernetes labels and similar. And again, like some examples of such labels, as I said, like these labels don't change, they're static while the application is running. Then we also have what we call sample labels, but we also call them dynamic labels. These are collected by the profiler itself, and they're embedded in the profile. To have these labels, you have to modify the application code. This is very similar to how if you have metrics, you can have custom metrics with your own tags. To do the same in Pyroscope, you have to use the Pyroscope SDK and define your own labels. In this example, if we use, for example, Java and Spring MVC, like maybe you have a middleware that creates labels for your controllers and controller methods. We have docs in our documentation about how to specifically add custom labels for every supported language. One last thing about this, like even though we have this division between different kinds of labels, once they're sent to Pyroscope, you can query them in the same way. There is no difference anymore. They're just collected differently. Now we're going to do a short demo about how you can explore labels in drill down in Grafana Cloud. So you can reach drill down if you don't know, like in the left menu here, we can reach profile drill down this way. The first thing we will see is a list of all our services. Now there are many ways how we can explore our labels. The most basic one is to directly go to the exploration type in the top, and this will basically pre-select a service for us, and it will show us all the labels that we have for this service. Another way is if you already know what service you're interested in, you can directly navigate to labels from the panel for that service here. And then if you're already looking at a flame graph for a service, and maybe you want to narrow down your data to a label, you can navigate to labels through this button here in the top right, which will show you the same view. What we see here is a list of all the labels, as I said. We can have different visualizations of the data. Here we have time series where we can see the overall like resource usage per label value pair over time. We can switch over to totals where we can see the total CPU time spent during the time window that we're looking at here, 30 minutes. We can look at histograms and other visualizations. We're going to talk about labels a bit more in other contexts as well, but the labels are present in the other views. So for example, in the flame graph view, we can filter our data using our labels. So we can select the label name and the label value. And the data that we see is now specific to applications that were profiled and were emitting this label value. If you have any questions about labels, feel free to drop them in the chat. In the meantime, I will continue on to the next topic, which is the Diff view. So what is the Diff view? Diff view gives us a visual representation of the difference between two profiles. This is important for a few reasons. Let's say you're deploying a new version of your service. If you want to spot like that something changed, that something like maybe you had a regression or maybe you improved the performance, you can use the Diff view to very quickly identify what changed before and after the deployment. In a similar way, if you have an incident, again, you can compare before and during the incident to see what changed down to the code level. And if you're looking for maybe areas to improve, and maybe you've noticed some differences across your different regions or different environments, you can use Diff view to compare and to find like which areas you want to focus on more, so that you can be smart about where you spend your time improving things. Talk a little bit about how it works. So we have two flame graphs here. It might be a little bit small to see, but these are like relatively simple flame graphs. The one on the left, we've spent a total of 4 minutes of CPU time. And in the one on the right, we've spent like 16 minutes of CPU time. Now, this one is a fairly simple case. And if we spend a little bit more time like comparing visually left and right, we can see that maybe this node where we have the order car method is bigger on the right side than the left side. But you can imagine if we have a more complex flame graph, it's not going to be immediately obvious what actually happened. So it would be great if we have something like the git diff but for flame graphs. And this is what the Diff view actually does. So now we see a third flame graph, which is a combination of the first two flame graphs, but it uses colors in a different way. So whereas in the first two flame graphs, colors define like packages or like where the functions are coming from, in the Diff flame graph, the colors show us what changed between the two. I'll first talk about how we built this a little bit so you have a better understanding, and maybe that will answer some of the questions you might have. But you'll notice that the total for the diff is actually the combined total of the two. So what we do technically is we merge the two flame graphs together by actually adding them up. This is good because if we have things on the right that don't exist in the left, they will show up in the resulting diff flame graph and vice versa. So this will allow us to see maybe things that are new and things that were removed. And then talk about colors a little bit, but it's important to note that the way that we color the flame graph is we don't use the absolute values that are in the left or the right, but we actually use the percentages or the share for each function. So let's say the order car function here takes like maybe 80 or 90% of the total, and here the same function takes 50% of the total. The coloring will be based on the difference between these percentages. So like if the percentage went from 50 to 80, then this is going to be more on the red side. And vice versa, if the percentage decreased, then we're going to color it green. And let's go for an actual demo again. I'm going to go back to, give me a moment. Yeah, I'm going back to Grafana, and then again, in a similar way to before, now we can jump into the flame graph directly here. So before we go further, I just want to highlight a few like visual elements here that might be important for you. Switch over to the checkout service first. So we have a left and a right component. We have basically like the timeline for the left and the timeline for the right. These are both for the same service, and right now they're showing the same data. We can change the range independently on both sides. If we don't want to click too much, we can also sync the time ranges. So like if we make a change on the left, it will reflect on the right side directly. As we mentioned earlier, we can add filters, but we're going to talk about an easier way how you can do that a little bit later. And then the last thing that is maybe confusing to some users is that we actually don't see a flame graph right now. And for that, we need to select what we want to compare. So I will go a little bit further back in time, because here we can see that something happened. Like there is a time when we had like a lower CPU usage, and then a time when we had a higher one. So on the left side, we can select this region of smaller, lower CPU usage, and on the right, we can select a different one. And we can immediately see what I mentioned earlier. Like we have two major flames that are now red. Like we have one here that comes from this place order method in our checkout service, and then there is another one here for our garbage collector. So what we can do from here, like first of all, like this is a regular flame graph, so we can do anything that we can do with a regular flame graph. We can change the colors. So like if you're colorblind like me, like maybe you want to switch to this view, because then we don't have a red and green, but we actually have red and blue. And we can then focus. So like maybe we want to see like what exactly is happening in this function, so we can narrow down like where is the CPU time spent. In this case, this is a deliberately introduced regression in this service where we spend time on compiling regular expressions, where ideally we should move this to the application startup and only do it once. but in a real world application, like we will see something different maybe. I want to briefly talk about this other part here. So we see that we spend more time on garbage collection. In the baseline, this was 12% of the overall time, and in the comparison, this is 20%. So it jumped by 70%. So while we're here, we can already switch to a memory profile and look at the allocations. And this will tell us why the garbage collector is working harder, which again will come down to the same method that we saw earlier, process order, but we can also quantify it now. We can see that in the baseline, 23% of the memory was allocated by this method, but in the comparison now it's almost 90%. So this part of our application is now predominantly allocating memory. So this was an example where I used a comparison across time. We compared a period of lower usage with a period to higher usage, which is what you would use during incidents and maybe when you deploy a new version. But there is another way that we can initiate comparisons, and that's when we notice that maybe the resource usage between different replicas of our application is uneven. So in this case, we see that. Let's go back to the CPU profile.
So for some reason, the resolution is being locked as 720. Would you be able to zoom in a little bit so that maybe it's a little easier for people to read text?
Yeah.
Oh, that one, the opposite way.
Is this helpful?
I think that's where it was before. Okay. Thank you.
Yeah, no worries. So looking at the CPU profile, and we notice that for this label, for the region label, we have a discrepancy in the resource usage. So for this region, we've used 2 cores, and then for the other ones, we've used less. So this sometimes happens because of difference in like the infrastructure, but often also the problem could be in our application. So what we could do is we can initiate a comparison right from this view here, where we can select the baseline, we can select the comparison, and then we can press compare. We go again to the diff view. Now the labels are pre-selected, and what we can do is we can use one of these presets to select the whole range for the diff view, and then we're gonna do something similar. We're gonna get a similar view where we can see what's different between one of our replicas and the other replica. Lastly, I want to briefly talk about the table view. So the top table, we did talk about the table in one of the previous community calls. It's a powerful tool to highlight maybe like where certain bottlenecks are. As opposed to the regular flame graph, this table uses percentages instead of absolute values. And because we use percentages, the values can be a bit noisy, but you can still get some insight from them. For example, if we sort by the baseline and we see which components were dominant in the left side, we see that, for example, here, this is the Pyroscope profiler itself. And we see that the profiler is now having a smaller share in the comparison than in the baseline. Now, you might think like, oh, the profiler is now more efficient, and that's very strange. Why is this happening? But in this case, this is not actually the case. This is explained by something else. This means that in the baseline, the application was maybe not very busy, so the profiler took a larger share of the overall CPU usage. But in the comparison, the application was doing much more CPU work. So the time that we spent profiling is actually the same, but the share is smaller. But if you do introduce a performance improvement in your application, this is where you'll be able to see that. Similarly, if we sort by the comparison, we will see things that became worse. Here, very quickly again, we will see that the place order function that we saw in the flame graph as well is one of the ones that is where we're spending more CPU time. Okay, I think that's it for the demo. Go back to slides. I'll do just a quick recap of what I talked about just now. We talked about labels, what are labels, and why do we use labels, the different kinds of labels, and then how we explore labels in profiles drill down. And then just now we talked about the diff view, what it is, when do we use it, how does it work under the hood, and we saw a quick demo. And now I will hand off to Alberto.
Yeah, thank you so much. And then I'm going to switch over to Alberto's slides. And yeah, anyone, if you have questions, please ask them in the chat. Thank you.
Cool, thank you, Alex. I'm Alberto. I'm another member of Pyroscope team. And today I'm going to present metrics from profiles, also known as recording rules.
I'm going to come in and ask a real quick question on the last topic before you jump in. Okay. Brian's asking if you can add a diff visualization to a dashboard.
It's a good question. I'm not sure if you can. I would need to double check that.
Okay, sorry. I'm going to.
Cool. Thank you, Brian. We can go through that maybe at the end, open explore and see how it looks like. Anyway, metrics from profiles. This is also known as recording rules. You will see why later. But yes, we're pretty excited to offer this feature. And let's just start with what is metrics from profiles. So metrics from profiles let you export profiling data as metrics to Mimir or any Prometheus compatible data source. So you may choose which profile matters most to you, and you may derive it and aggregate and send it to Mimir so you can consume it differently. So we are moving from flame graphs, which are pretty convenient for a lot of tasks, are very expressive on how resources are being spent, but you can also start seeing consumptions as metrics, which are also very familiar and sometimes are more convenient because we have this time point of view. So what are metrics from profiles? Why you should adopt metrics from profiles, or what advantages can you take from metrics from profiles? So we started this project because we wanted to offer alerting from profiles. We found that there were a lot of people interested on alerting, profiling data, and we didn't reinvent alerting, and we just wanted to use like the custom alerting system on Grafana, and we thought that the easiest way would be to just export profiles data to Mimir and just start there. We found that this kind of data is pretty useful and is filling some gaps that we are not currently supporting on the UI, on the read path. And here are a list of things we are using right now at Grafana Labs for metrics from profiles. First of all, we now unlock alerting. We can alert on consumptions. We can alert services that are consuming too much. We can find functions that are increasing also the consumption on percentage, for example, and we can just out of the box of having Mimir in the middle, we unlock alerting. Same for dashboards. We can now create dashboards that explain consumption over time instead of using flame graphs. What else? We believe that one of the most important or more useful feature of this is that you can target functions. You can choose to export metrics on specific functions, which means that you may understand how a function performance goes over time. Imagine you are deploying a new service version and you are releasing a new library version that you've been working on, you may see how it affects on real time. You may see how it drops and how it increases. And you can also compare with other services or other installments between pods, between regions, wherever you want. Another useful case we found in Grafana Labs was to do cost allocation. So we have these big services that are shared by a lot of teams. We have gateways, we have load balancers, we have distributors that are shared by multiple teams. And it's sometimes hard to allocate cost once the bill arrives. And now we can know for sure, according to data, which resource is being used by every team, so we can split the bill more accordingly. And finally, there is a cool feature we found, cool also advantage we found, that we can find which service is running a dangerous function once a CVE is published. So we found this function that was dangerous, and we just created a recording rule, and we could find over time which services were using that function. There is a caveat here. We can really trust on the probabilistic nature of profiling. So maybe there is some service running the function, but you don't really know because, yeah, it's probabilistic. Maybe the profiler cannot hit any instance of the function being run. So yeah, there is it may be a bit risky, but it can be a good starting point to find vulnerabilities. How do you do metrics from profiles? So you do it from recording rules. Recording rules is a name we found convenient because a lot of people in the community is familiar with Prometheus recording rules, and also because it explains how it works. It's a rule that records data. Recording rules let us choose which data to export. So you can have a filter on a service name. You can have a filter on any pprof label. So in any label that Alex just explained, you can also optionally have filters on function names. And you can also explain and you can also define how you want to export. You may choose a metric name, and you can also choose some set of labels that you want to export to be included on the metric. Why is recording? Because once the rule is created and after the rule creation, any ingested data that matches the rule will be exported, not beforehand. So anything after the rule creation. Data is aggregated and exported to Mimir. And yeah, we aggregate through these group by labels here, which is the ones you choose to be exported. And that happens at ingestion time. Let's do a demo. Let's see how it works. Cool. To do metrics from profiles, you will need to start here at the Prometheus recording rules icon here on the top
Can you zoom in a
corner.
little?
Sorry?
Could you zoom in a little bit?
Yeah.
Thank you.
Thank you. You can create a recording rule from here. You can choose add recording rule. If you are now using Pyroscope Cloud and Grafana Cloud, you might not find this. Yeah, you will need to enable this. Yeah, I'll have some words later about this. But yeah, once this is enabled, you will be able to create a recording rule from here. So now we are at the all service view, which means that we are looking all the services, and this context will be carried on to the add recording rule option. So once we click here, we will see that the recording rule we are going to create is targeting all the services. As I said, we want to tell how to export. So we want to tell the metric name and the labels we want to export. And we want to say to the recording rule how to export. So, sorry, what and which data to export. So now let's create a very simple recording rule. Let's export every CPU contribution as a metric to Mimir. Something like this. So I will create a metric name called profiles recorded CPU nanoseconds. I'm going to export as well the service name because I think it's important. And this recording rule will target every service. This also
So
targets.
the part that you put at the end is what is coming directly from, like a specific Prometheus metric name?
You mean this?
Yeah, is that based on, like, is it something that you're deciding or based specifically on what the Prometheus metric name is currently called?
I mean, I decided this, but this follows the
Okay.
convention. The convention is, thank you for asking, Tiffany, this is very useful. The exported data is a gauge, it's not a counter, and gauge are conventionally suffixed with the unit. So in this case, as we are working on CPU usage, I know this is nanoseconds, and that's what I'm trying to export. Then let's check the filters. The filters are fine with the view we were working on, which is service name, all services, profile type CPU. It's the one that I choose here. I will leave function name empty. I'm not interested in export any function name yet. And I'll choose not to target any other filter. Service profile type is enough for me. So let's create this. Cool. Once the recording rule is created, any ingested profile that matches the rule will be exported. It takes about 1 minute to start recording. And sometimes it maybe 1 or 2 minutes. And also every exported profile will have the ingested time stamp, which means, yeah, even if you see a bit of a delay, don't worry, data is with the correct timestamp, the ingestion timestamp. It takes some time to see the data, so let's wait like 1 or 2 minutes. In the meantime, let me explain you something else. So the context that is brought here when creating the recording rule depends on where you create the recording rule on this flow. So for example, if you are looking at the checkout service and you are filtering by region and you create a recording rule from here, you will see that the filters are brought as well as the service name and profile type, of course. Let's go to explore. Let's see if the recording rule has already started recording and we can show some data. This one. Cool. So we have already some data. Let's craft a query from this. Let me use a sum by service name, which means that I can see that the series, in fact, targets every service on our Pyroscope. It will take a bit to be cool, but yeah, we're seeing that more services are joining. As I said, the exported metric is a gauge, which means that every profile that arrives will change the gauge. It's not a counter, so it's not cumulative. That means that reading this data can be a bit tricky sometimes, as profile contributions can drop and increase like abruptly. To deal with gauge, we can use the sum over time function that let us define a time window in which we want to aggregate over time, which means now I'm aggregating the gauge over time, so I'm minimizing this drop and effects that can appear from changing the gauge drastically. And this will help me understand the ingested data better. Let's see some dots, some points here. So for example, this one is 1.2 billion nanoseconds on CPU consumption. What does this mean? In this minute, because I set a 1 minute time window, there was a spend of 1.2 billion nanoseconds. Let me divide just to easily understand the units. Okay, now this is seconds. Let me use also this. Maybe if we use another step, we can see data more cool. Okay, now we can start understanding this metric, which means checkout service at this minute took 2.33 seconds on CPU spent for every minute it was running. So the last minute this was captured, it just spent 2 seconds on CPU, which is pretty low. But still, we can see from the metric that the checkout service is the highest of all of them. Cool, I have some dashboards prepared because, as you see, recording rules may take some time to show cool data. So I just created these 3 examples, and we just did the first one. So we have this CPU usage by service name, and here we can visualize the CPU usage of every service on 10-minute windows, which means checkout service here spent 19 seconds in the last 10 minutes of execution. Now let's do this second other example. In this other second example, we are just focusing on the checkout service. You will see that this line is the same as this one, more or less. So we are going to export. We are going to target this service name, and we are going to split it by region. This is something we can do with recording rules, and let's do it. Let me go back to the profiles drill down app, and let me choose checkout service. From here, I can create size of a recording rule. I just want to export this service CPU contributions, but I want to also include the region label, which is important to me. If you remember Alex's example, he showed that there is a region that is contributing a lot more on CPU than the others, and that's also something we want to see from metrics from profiles. Let me name this function, the recording rule as profiles recorded CPU checkout service nanoseconds, which means the CPU contributions of this service in nanoseconds. I'm going to add the region label because it's important to me. Let me check the filters are fine. Checkout service, CPU, no function name, no other filter. It's okay, and let's create. Cool, as I said, it takes a bit of time. We should be able to see something similar what Alex showed, which is that there is a region that is spending more. And then I want to, let's not wait. I mean, we could see here on Explore or metrics, drill down app, we could see the profiles, recording rules that I just created. This is the first example. The second example hasn't shown yet. So yeah, it takes a bit of time. So let's move to the dashboards I created. And as you may see, it's been running since the morning. This works as you can see how every service, so how every region is contributing to the checkout service and CPU total. Finally, let's do our favorite example, which is targeting functions. And we're going to create a recording rule that show us which service is spending more on garbage collection by percentage, which is a pretty interesting thing that we cannot really do right now from the profiles drill down app UI. Cool, so let's move to the checkout service and let's take any service as an example, accounting service, for example. You will see here that there are some garbage collection, this one. This function name is known to be like the garbage collection thread doing draining jobs on background. And this one explain us how this garbage collection worker takes 5% of CPU on the service. We cannot really compare how the CPU on garbage collection goes on other services from this view. We are just on the accounting service. We don't know about other services, and we don't really know how the garbage collection evolves over time. This is something that the flame graph cannot explain, as this is just an aggregate of all the last 30 minutes. So we can improve this by just exporting as a metric and visualizing on another way. There is a hidden way of creating recording rules, which is from the frame graph. You can choose any node to create a recording rule. So for example, if I click here on the total, I can create a recording rule. It's the same as if I was clicking on add the recording rule, but you can also target functions by clicking on their node. So for example, I can choose to create a recording rule for the garbage collection only. This is how I would create a recording rule for this service and for garbage collection, but I want to create for every service. So I'm going to copy this function name, and then I'll move to the all services view. I'll create a new recording rule, and I'll use this function name as the function name I want to target. Now I can create a CPU function, garbage collection nanoseconds, for example, metric name, and I can include the service name, which will be the one that will let me understand which service is spending more on garbage collection. I can create that. It will take some minutes to have insightful data. But if we go to view recording rules, you will see that there are the 3 rules that I created in this demo, and the other 3 that were created this morning. Then if I jump to our demo dashboard, we can see real data on this. As soon as we have CPU usage by service name, once we have CPU usage of garbage collection by service name, we can compute the ratio, and that's what I'm doing here. Let me show you. Let's go to it, and let's see how I'm just dividing the garbage collection nanoseconds contribution for every service by the CPU contribution of every service. So that's how we know the checkout service is spending around 20% of CPU usage on garbage collection, and we can see how it evolves over time. We can also compare to other services, for example, accounting services, accounting service that we were seeing before. That one had an example of 5%, and now we know that over time, over the 3 last hours, it has more like a 7%, and we can see how it increases and drops over time. Cool. Any questions so far?
I have a question. So like right now you have your profiles and you're specifically creating metrics based off of your profiles. If say you are collecting your profiles and you're collecting Prometheus metrics in general, is there any way to be able to like connect those two if they're already existing, or do you have to create your own metric from your profiles to do that?
So for right now, you will need always to create a recording rule, and you cannot really link to any other Prometheus metric existing. This feature can certainly evolve in some directions. We have an example where we create different recording rules and we target the same metric name. So we are aggregating results from different metric rules, and there is some other hidden features where you can tag the metric name. So you can tag series coming from one rule and series coming from another rule, and aggregating them together with a new tag called first rule, second rule. And that's how we did, for example, in cost attribution, where we had recording rules hitting one service and recording rules hitting another service, and they were being exported at the same metric name, but we have a new label called dim that can distinguish them. So feature can advance and can clearly evolve, but we believe this is in a good stage that can be launched, and yeah, we are pretty happy with the current state, and we're just see how people start using this, and maybe they found new creative ways of taking advantage of their profiling data that's been sitting there on the Pyroscope, and maybe you cannot really extract all these insights without this function, this feature. I just want to mention that it's pretty obvious, but once you have this as a dashboard, you can just create alerts out of it, pretty easy. Yeah, you can use any Grafana stack that relies on Prometheus. It just gets unlocked. You can create Prometheus recording rules from this metrics as well. Yeah, anything you can do on metrics will be able to be done. Yeah, you can do it on profiles now. Cool. So let me go back to the slides. Yeah, so we are looking for feedback. Any Grafana cloud user can request for use to use this. You just need to ask to the support team, and this is available only on private preview. But yeah, you can use it already. Any open source user can use it. It's available in the last version. It's been available since older versions, but this is a quite experimental thing. I would recommend use the last one. And yeah, just take into account that you need Pyroscope V2. And if you have any problem to set up, just reach us on our Grafana Labs community Slack. And that's all. I'm from the Metrics from Profiles project. Any questions? Yeah, just chat and we will answer.
I have a question. So say you have created a metric specific, like you picked some, like your CPU nanoseconds. What would happen if you tried creating another one with the same name? Does it just like tell you, hey, you already have this, or like?
No, but there is. So if I created this twice, so let me share again Periscope. If I created this twice, right?
Yeah.
Well, it depends how you query it. If you query it like this, let me copy and go to Explore and explain it properly. So if you go to Explore and just query like this, you will see that there is a profile rule ID here that distinguish rules. So if you are doing some security conditions here, like profiles rule ID, zoom by. So if you are doing a query such this, you shouldn't have any problem because every rule will have a different rule ID. But if you are not using this, yeah, then your metric will be magnified. Like you are adding in the same metric two different things, and then you will have this. I mean, we're not limiting this, but because maybe people want to add two different sources to the same metric because it's relevant for them.
Okay, so there's a question of, is there a way or plans of a way to collect historical metrics? For example, instead of starting the recording rule at a creating time, it uses data filled for the past week.
So right now, this is not supported. I think that it's not too crazy to think that this is possible. It's just maybe you just don't want to do an ingestion time, but maybe you want to export something that goes from a query. I mean, I believe that Pyroscope has increased in performance a lot, and we were not supporting such type of queries. So give me garbage collection information for the last week. That's not allowed. But yeah, taking into account this feature is only filling a gap that is not supported right now, but maybe in the future we can support such type of queries, but not right now with recording rules. There is no plan for that.
Okay, and then yeah, folks keep asking questions. I'm going to switch it over to talking about 116.
Yeah, so the last bit for today, yesterday we released Pyroscope 1.16. Has a long change log, which you can access at the link at the end there. But what we want to highlight is that we added support for ingesting profiles in the OTLP format over HTTP. We also added a brand new Helm chart for monitoring your Pyroscope installations. It's based on the monitoring that we use internally at Grafana. We added a UTF-8 label name client capability, a few performance improvements, and many bug fixes and security patches. So you can see more on the link, as I said. And I think that's it for today.
So is that the first time now that you can actually use OTLP for Pyroscope then, or was there something beforehand like for gRPC, or is that not there yet?
I don't know. I remember the details. I think this adds another way to ingest OTLP. I think it was already a possibility before, but I would need to double check that.
Okay, so basically just making it more easy for, like, say if somebody's already, like, I don't know, collecting traces and they have all their stuff set up there, and now that there's less that you have to specifically change or do to be able to get Pyroscope as well.
Yep.
Yeah, so yeah, if you have any questions, please ask them in the chat. Otherwise, if you missed asking questions now, whether it's right now or if you're watching this video after the fact, please go over to slack.grafana.com. I see that's not on there, so if you go here, wow, that's huge. If you go here, basically, you can go and join us in the Slack, and there's a channel for Pyroscope and can talk to us over there. There is also the forum, which is community.grafana.com. So yeah, I guess in the meantime, thanks so much for both of you for doing this today. And thanks to everyone else. Also, if any of you have ideas about things that you would want to have in a future community call or things that you want us to answer in a future call, please let us know. Also, if there is something that you are like, oh, hey, I would love to try showing this sometime in a community call, please just reach out to me on the Slack. I'm just Tiffany on there, and we can discuss that as well. And then we'll also continue doing more of the parts where there's like the intro things for folks who are newer to profiling as well, in addition. And then, so the next one will be next month. So yeah, thanks everyone for joining. And I don't see any other questions at the moment, so I will just hope to see questions over in the Slack that we have. So thanks everyone.